Hello, I'm Kyle. I'm the technical content developer at Maple Systems. Welcome to the Maple Systems video training series. In this video, I will be configuring a high-speed counter in MapleLogic using a PLC ES0808P to measure the speed of a motor with a Quadrature encoder. In my ladder diagram logic, I will have an alarm turn on if the speed of the motor exceeds a certain amount of revolutions per minute, and I will be simulating this using a live camera feed later in the video. Here is a diagram on how you would wire a Quadrature encoder and motor to a Maple PLC. A PWM speed control is controlling the speed to the motor, and a 4-wire rotary encoder, or Quadrature encoder, is measuring that speed and outputting to a Maple PLC. For the speed controller, DC plus and DC minus are going into a power supply, and the motor out plus and the motor out minus are going into the motor. Another power supply is supplying 24 volts to the PLC. The 24 volts from the encoder are going into the COM on the PLC, and the 24 volts from the PLC is jumpered to that same COM. Also, make sure the 0 volts from the power supply is going into the ground on the PLC, and 0 volts from the encoder is going into that same ground. Also, you may be able to use just one power supply in your setup, depending on the amount of current you are able to provide. Now, back in MapleLogic, let's configure the high-speed counter configuration window. In the previous video, what is a high-speed counter and how is it used with an encoder, I went over these settings in this window, so I recommend watching that video or visiting the Maple Systems website and read through the what is a high-speed counter and how is it used with an encoder MapleLogic tutorial page. So the first setting here, count mode, will be set to linear, as we are just going to count in one direction. For pulse type, I have 2-phase 4 multiplication because I'm using a 2-phase Quadrature encoder. I will be using a compare instruction in my ladder logic, but I will go over that in a little bit. So I'm going to leave these settings blank because you would only use them if you were comparing to the count, but in this case we're comparing to the speed of the motor. So these 3 settings here, unit time, pulse per 1 cycle, and RPM, are the settings we're going to pay attention to. So unit time is the amount of pulses that the encoder outputs to 1 revolution of the motor's shaft, and then 1,000 pulses per 1 cycle. And then this setting, in order to initiate RPMs, you'll set this to 1. So next, we're going to build our ladder diagram. So that's going to be in a normal scan program. So I created one here. I'm going to open this up. So in my ladder diagram, the first rung will turn on the RPM flag. This must be turned on to use the RPM function. The instruction is set and then D116.5. So if you open up your help file in MapleLogic and then go to the built-in high-speed counter and then parameters and then scroll down in your parameters, you'll see in this area here, you can see your control bits. So you can see that it's 16 and then bit 5. So if we weren't starting at D100, it would be D16.5, but because we're starting at D100 in our high-speed counter window, we're going to start at 100, so it's going to be D116.5. If you were using PPS or pulse per second, you would also use the same bit 5, but in your high-speed counter configuration window in MapleLogic, you would set this to 0 instead of 1. Let's go back to MapleLogic. So you can see here it says set D116.5, so this will turn on the RPM bit. And then on our second rung, I'm using a compare instruction to turn on an alarm if the speed of a motor is greater than or equal to a certain amount of RPMs. That will turn on the alarm, and in this case I have it set to 1800 RPMs. If it hits 1800 or goes beyond 1800, it will turn on Y10. Then if it drops below, the alarm will turn off. So that is it for our ladder diagram, and that is also all the configurations in the high-speed counter window. So now we can just go online and do a live simulation. So go to online, link plus download plus monitor. Okay, now we are online, and first thing you want to do is make sure that the enable count is checked off, or if you didn't want to check it off, or if you just kept forgetting to check it off, you could build some logic and have F10, the always on bit, turn on the enable bit, which would be an instruction set 116.0 because 0 is the enable count bit. And you can see that information here in your help file, the same area that you found the RPM enable bit. So here is counter enable bit 0, so it would be 116.0 to enable the counter. Or you can just check it off here. So in this example, I'm just going to check off enable count and then click monitor. And you can see the enable count status flag is on, as well as the RPM status flag is on as well, because we have our logic set here to turn on 116.5, which is the RPM flag. So next, I'm going to start the motor, and you see the speed of the motor gradually increase, and then when it hits 1800 RPMs, it will turn on the Y10 alarm, and when it drops below, it will turn off. So I'm going to start the motor. And as you saw there, it sped up past 1800 RPMs, and it turned on Y10, and then it dropped below 1800 RPMs, and the alarm turned off. Now, because I have a two-phase quadrature encoder, I have the ability of going in two different directions, forward and reverse, on my motor. So in your high-speed counter window, you will notice that the speed is a positive number when it's going forward. When it's going in reverse, it actually shows a negative number in the RPM measurement right here. So I'm going to show that real quickly, and then you'll see it change from a negative when it goes the reverse direction. And so you saw it go forward and it was a positive number, and then when it goes in the reverse direction, it changes to a negative number. This is all I'll be covering today. To get more information on high-speed counters, please visit the How to Measure Motor Speed Using a High-Speed Counter with a Quadrature Encoder tutorial page on the Maple Systems website. I hope you enjoyed this video, and thank you for watching.